So the Z1090 is running in a basic installation mode, just straight out of the download from the IBM site. I've changed the password for the IBM user. I've added 3 new volumes to the device map. I think that's very easy to do, so I'm not recording that bit. And now we're going to initialize those volumes and make them SMS managed so that we can store our own data sets on those volumes. So let's log on this brand new system. Yes. And then we better start with creating a library for all our jobs. I think the parmlib is a very good example of some allocation specifics. So I'm gonna do this, and do this, and we are gonna create an IBM user.setup.jobs. Don't like that. I think that should be more than enough. So now we have hopefully our setup jobs library, but it's still on one of the user volumes that comes packaged with the image. We have to add our own volumes. Let's see, I've added the volumes to M5 AA0 AA1 to 3. So this one's offline and not ready, so we have to create a job to initialize that dest volume. But of course we don't have any jobs yet, so we have to start with that. I always start with a job card, and then we don't know what it is, but we're just going to do step exec equals IP14. Let's just submit that. That obviously works. I'm going to switch. We're going to go here, get rid of this old stuff, and then this is our little handy job. Card template, and we also want to highlight everything. That looks a lot better. Well, it's time for our first job, so we will call that job 1 init. Now we can just copy our job card over, and we have to write ourselves a program called ICK-DSF to initialize the dust volume. So we will change our step name to init1 program equals ICK-DSF. That will initialize the dust volume, but it will write to the operator to reply that it's okay to do so. Seeing as we don't want to switch back and forth to replying, we are going to say parm equals no reply you, meaning that it won't ask for a confirmation. Out of experience, I know that this thing wants a bit more memory than the default, so we're going to give it a bit more memory by specifying 0 megabytes. That's about it. Of course, we want to see some output, and we have to give it the control statements on what we want it to do. Make that inline, and we are going to initialize a unit on unit address 0AA1 as specified in your device map. We're going to verify the previous volume label, which of course is nothing. We're going to give it a volume ID. I think ZDevOps 001 is a very nice volume idea. We're going to make sure it can be SMS managed, storage group, and that should about do it. Just to verify that our unit is offline. Display unit. Yeah, it's offline and not ready. So we will submit this job. Well, that looks kind of cool. Then we're gonna do another display. Now it's offline. And we're gonna vary it online. AA1, online. And let's display it again. Well, that's nice. Now we can resume, or well, do this again for the other two volumes, and then we should be golden. I will pause the recording just for that and show you the end results. Okay, so we're back. I've altered the job a little bit, gave it some extra information up here, made it a bit nicer, with some comment lines, and repeated this step 3 times. Submitted the job, and then we can see we have our 3 new volumes available on the system. Just to be sure that they are also there. Well, that all looks nice. So now it's about time to maybe define a high-level qualifier in the system so that we can guide that high-level qualifier towards our new volumes. For that, we need to create our high-level qualifier, make a user catalog entry, and all those kinds of things. So let's start with the user catalog maybe. We'll go back to our library with handy dandy little jobs. Oh, it's already here. And now we're going to make job 2, which is the user catalog. Well, before we do so, we better make changes to our template job card as well, so it all looks a bit nicer. Take this away. Let's do it the handy way. Copy this one. Get rid of all those ones. That one there. That's better. So we're gonna create a J2 ucat. We're gonna copy in our job card, and we're gonna use the program called itcomes, idcams maybe, I don't know. Specify what it does. Make sure we get some output in case things go wrong. Just this pool, and then the control words for itcomes is that we are going to define a user catalog. We're gonna call it usercat.zdo. Continue on the next line. It is going to be an ICF catalog, and it's going to be big enough for all the data we're going to store. I'm not quite sure, but I think this will do. And our input. Create user catalog. And maybe we can just submit it. No. What went wrong? Well, I know what went wrong. We made a big typo here. I'm going to submit it again. Something else went wrong. Well, we better take a look then on what happened. Get rid of some old stuff. Now let's take a look. Petition pronounced on the D7. Ooh, yeah, invalid. Yeah, of course that needs an equal sign. That's a lot better. Let's see what it tells us. It tells us that it created a nice user catalog. Let's see if we can find it. Yeah, it's right there, straight at the top. So now we better make sure that we can actually define some high-level qualifiers and have an alias so that all data sets that are allocated that start with ZDO will be allocated or at least cataloged in the user catalog we've just created. So it's time for another job. Job 3, HLQ. Let's bring in our job card. This is going to be create an alias. For this we use it comes again. Specify what we're doing. Create alias in master catalog 2.2 user catalog. As before, we want to see some output. Specify it correctly this time. The input for it comes is as follows. We are going to define an alias with the name of ZDO. And we are going to relate this to the user catalog .ZDO. That should probably work. Let's try and submit this. 0. Of course we're going to check all the way down and it says, well, it says that it's good. So now when we go to 3.4 and we list the high-level qualifier ZDO, it's an alias and we can list cut this entry, look at everything, and maybe not make typos. It's cataloged in the master catalog and it associates to the user catalog we created. So that all looks good. Now we should create our high-level qualifier, because this was just the alias, and we'll make another job for it. We call it J4HLQ again. We'll copy J3HLQ without typos. We're going to now create the high-level qualifier. For this, seeing as we already have the alias, we don't need to do anything for it, but we need to make sure that our lovely friend RACF will allow us to create those data sets, that we have access to them, and that we at least have some form of initial protection for these data sets. So we are just going to use TSO in the batch. Perform some RACF commands. The DD name is a bit different for IKJEFT01. Has the T for TSO in there, or the TS probably, and now we can specify our commands. First thing we need to do is make sure that we have enhanced generic naming for RACF. meaning that we can specify profiles like sum.**** stuff instead of fully specifying them. So make sure that that's switched on. We also have to create a group that shares the high-level qualifier, because otherwise it'll be very hard to create dataset profiles starting with that high-level qualifier. So we are going to make a group ZDO, which is owned by me at this point. The superior group is going to be sys1 and some installation data that says the high-level qualifier for ZDO. There. Then we need to probably add a dataset profile for everything that starts with ZDO, and we're going to make sure that nobody can touch those. We are going to permit the same profile in the dataset class, and we're going to give read to everybody who's logged on. That might be nice. We are going to also say maybe want to protect that user catalog as well. Maybe, but maybe we'll do that later, see what happens. So we leave it for now the way it is. But of course, no, we better add it so that we're sure that people can update to that user catalog. So we're going to add an entry for usercat.ZDO, the one we just created. Also with a universal access of none. And we're going to permit usercat.ZDO in the dataset class. And we're going to give updates to everybody who's logged on. And then we're going to refresh all the classes for the RACF dataset class, generic dataset refresh. Yeah, so this should do the trick. We are just going to submit this, and we get a return code of 0. We are going to check our output. 5, please. Let's see. Ready, 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 ready. Everything okay. So when we now do a TSO list dataset usercat.ZDO, that's funky. Should be there. Let's go into the other thing, the lovely RACF panels, dataset profile search, usercat, no entries. What happened? What happened? Oh yeah, well this of course failed because we didn't have a usercat group. So we better change our little job stream. Like I said, you can't define it if there's no group. So we're gonna define this userget group, and we're gonna call it usercat HLQ. That fits. Submit this again. Check our output this time. Yeah. This is better. So now TSOLD dataset usercat.ZDO. ZDO should work. Yeah, that's good. So after some troubles, we have now some security for all ZDO datasets and the user catalog. Now, how do we get the system as crazy so that every dataset we allocate that starts with ZDO will be allocated on our freshly generated new volumes? For that, we need to go into ISMF, like the SMS configuration screens. They are hidden away in M, and then option 2, and then we don't have enough options here, so we better switch ourselves to storage administrator, profile, user mode selection. Please make me an SA. Thank you, thank you, thank you. Out and back. Now we have some more options. This is good. We first need to try and find out where all the ACS routines, which is the code that directs datasets to specific volumes, amongst other things. So we're going to have a look at the automatic class selections. We're going to display all the settings for the active configuration, and then we get a nice little dataset name, which is the source dataset where the routines have been translated from, and we have to make some changes there. So we better copy that so we don't forget. Head back to our jobs. We're not going to do this with jobs, but just so that we have a little external memory. So this is going to be select J5 ACS. ACS source datasets there. We also need to know what our configuration dataset is so that we can activate it later on. For that, we will leave this area for now, go to SDSF and execute a display SMS, and that will tell us that our SCDS is right here and our ACDS is right there. We need the SCDS, so I'm going to copy this over back to the source here and say SCDS equals column that one. Good. Save. Away from this, back to ISMF. No, not back to ISMF. I'm going to edit these ACS routines from here. We will start by editing the storage class. As you can see, there are already some nice high-level qualifiers defined that the dear folks at IBM have set up very nicely. So we are just going to steal from them. Thank you very much. And we're going to call that ZDO high-level qualifier, and we're going to say everything that starts with ZDO dot star star. Make it star dot star star because we can't ever do the alias. So get rid of those. So that will trigger on all files that match this here pattern. Let's see what they do. FDB2. Oh crap. Better cancel out, huh? Edit. Do it again. Repeat, repeat. Repeat, repeat. ZDO HLQ. ZDO.star.star. Close. Away. Make sure it's uppercase. Let's see what they do. When the data class, we don't want this, we don't want this. This is what we want. So when the data set is ZDO high-level qualifier, we're going to give it a storage class of ZDO just so we keep things specific, and exit our routine. We are going to save this in our little description. store class ZDO.star equals that, which we have to create later on. So from the storage class we're going to hop on to the storage group. This is what actually defines our direction towards volumes in storage groups. Let's just see what they did with DB2 here. Oh, they use some nice overflow pools. We're not going to do that for now. It is not very interesting. So we're going to say when the storage class equals the one we did, we're going to make a storage group called that, and that's enough. I'm going to keep this. Put it in our external memory. That kind of looks good. So now we are going to have to create our storage class in our storage group. For this we finally go back to ISMF, option 2, and let's start with the storage class right over here, which is option 5. We don't want to do this in the active environment because that would not be smart. We luckily stored this here, so we're going to take this data set, paste it there, and let's first have a list, see if it's all okay. Well, that looks okay. So we are going to define option 3 a storage class that we will call SCZDO. Press enter. The storage class for ZDO things, whatever. All these things don't really matter much. They don't really matter much. We're just gonna save, keep the defaults, get out of there. Saved, so that's good. Get out of here. Then we're going to define our storage group, which is option 6. Again, make sure this data set here is the correct one, and we are going to create SGZDO, and we are going to define it. We have to tell it what kind of storage group it is. Virtual I/O, a pool, a dummy thing. You can do things for tape. We're not going to do either. For now, we're just going to call it a storage pool. Let's define this thing. The storage pool for ZDO things. These options are very nice once we set up HSM in the near future. That will manage all our storage and take backups of datasets and migrate them away. So we're gonna want to keep these two on yes. We don't want dumps. It's definitely not an overflow pool. We'll just leave all the defaults. Keep our disks 85% full at max, and we need to enter the backup frequency. So let's take a backup every 1, right? Press F1, and there we go. F3, storage group defined. Now we need to take a look at the volumes. We have to define some volumes. We can say I want all the volumes that start with ZDO from 001 all the way up to 003. Press enter, enable it for this system, press F3, all volumes defined. So when we now do a display, I said a display, oopsie daisy. Let's do it again, 6. When we do a display of this storage group, kind of looks good, right? Time to translate our routines. We're going to translate in what CDS, I don't remember, but it was this one. That's why we write those things down. Maybe it needs quotes, probably needs quotes. The source data set I kind of forgot, so we're gonna have to find out what that was called again. Alright, we do remember what that is. But we need the name as well. So let's keep this, this, and this. Not here, but here and here, and IBM user setup jobs. Remember this one, it is this thing. And now we don't remember what the name of the members are, so we are going to just split new, 3.4, go here, go here. Well, obviously, copy those so we have them in our memory. Member names, ACS source. There. So let's start with our store class. And yeah, we want to see some listings. Out list. Here it goes. It's translated. We see the full source. And it kind of looks good. Bye. Oh, jeez Louise. We don't want this. Now we want the other one, which is store grp. Compile that one too. Scroll all the way to the bottom. Looks good. Let's try and validate our CDS. Validate everything in the validation list, and no warnings. Validation successful, so maybe it's good. Time to get out of here. Go to our, let's see our control data set and activate it. Option 5. Are you sure? Yes, we are sure. It says activation scheduled. And there's a nice message that says a new configuration has been activated. Well, now that we've translated our ACS routines and activated them, we're going to have to see if it all works. So that is what we did it for. TST it. Copy our job card. Test our allocation. Make sure the quotes are right. Our favorite program. Allocate. Dataset name equals setio.tested.dataset, comma. Well, obviously we want to catalog it, just in case IEF BR14 abends. We'll delete the dataset again. We have to give it some space. We have to give it some DCP data. Record length is 80. Record format is fixed block, and the block size. Well, we don't do a block size because SMS will calculate that for us, I hope. If I did not make any boo-boos, this should just run. And it doesn't. Woohoo! What went wrong? Let's see what went wrong. No. 3 M5H. Get rid of some of our old junk. Let's see what we did. Unidentified positional parameter in the disk field. 3. Oh yeah, duh, it's even shorter. Catalog, comma delete. Submit. Now, success. Now we are going to see if everything happened according to plan, which it did. We can see that this is now stored on the ZDO3 volume. Let's see what block size it calculated for us. Don't we see it here? We don't see it here, I think, do we? I don't even know. Why is this all so weird? There. Can we edit this? No, there was no block size, so we need to do something in SMS to configure block sizes. For now we will delete this. That's probably because we didn't do anything in the data class for that. That's something for another time. Delete this. Go here and just add the block size of 80. Highly efficient blocking. Ooh! Now it went to volume 1. Well, that's all good. You can edit this thing. Hello, first data set. 1 less S. Cool. So that's volumes done, user catalogs, high-level qualifiers, and initial SMS configuration. Yeah, probably time for a break of this video, and then the next one we will do some user setup, make sure everybody can use OMVS, make sure auto git and auto UID are working to ease our adding of new users that we test with, and maybe set up some auto mount activity in the USS environment now that we have SMS up and running. Yeah, that's me out for now.